Hello everyone, I welcome you all to this class. This is mathematics class. We are here again to look at another important example on this topic. We considered in our previous classes, we considered the topic domain of a function. So we define the domain of a real valued function. We are going to look at the definition again. Assuming that f is a real valued function of real variables, then the domain of f is the set of all x elements of real numbers, set of all real numbers, such that f of x is what? A real number. Which means that the domain of a function, of a real valued function of real variable, is a set of all real numbers x, such that if I put them in the function, if I put them inside f, the function f, I will also get what? A real number. So in this fifth example, we want to find the understood domain of this function. Whether you are told to find the understood domain or you are told to find the domain of the function, they are all talking about the same thing. So we want to find the understood domain of the function square root of x minus 2 divided by x plus 1. So let me call the function, let f of x be equal to the given function square root of x minus 2 divided by x plus 1. This is the given function, right? So we want to find the domain of it. But if you look at this function, you could know that this function is a root function. And inside the square root, we are having what? A rational function. Now, a rational function is a function expressed in fraction form. We have the numerator x minus 2, we have the denominator was x plus 1. So this is a rational function, and we have what? Square root. Both of them has conditions for domain. Now, for square root, we don't have square root of negative numbers. So any points that will make what is inside the square root to be negative, we are going to remove it from the domain. It will not be part of the domain. Then for rational function in fraction form, we don't want the denominator to be 0, because if the denominator becomes 0, you get what? Infinity, right? So the domain of this function, this quantity should not be what? Negative, and the denominator should not be what? 0. It shouldn't be negative because of square root, and the denominator should not be 0 because of this rational function, because the denominator becomes 0, you get infinity. So we are going to say that the domain of this function f is what? The set will be equal to what? Set of all x elements of real numbers, such that what is inside the square root is what? X minus 2 divided by x plus 1 should be a number greater than or equal to 0. It shouldn't be negative. The denominator of this quantity should not be what? What's the denominator? X plus 1 should not be equal to what? 0. So if I want to say that x plus 1 is not 0, I will write x plus 1, I will put equal to, I will cancel it. I'll put equal to 0, I'll cancel it. So it means x plus 1 should not be 0. So this will be the set of all x elements of real numbers, such that x minus 2 divided by x plus 1 is greater than or equal to 0. And if you solve this one, what will you get? If you solve this one, x plus 1 not being equal to 0, this thing is not 0 if you move positive 1 to the right, you are going to get what? Negative 1. So for this x plus 1 not to be 0, it means that x should not be negative 1, because if you do negative 1 plus 1, you get 0. So x should not be equal to what? Negative 1. So I say x is not equal to negative 1, I put x equal to negative 1, I cancel it. That is, it means that it should not be equal to negative 1. And you understood how we got negative 1? By moving this positive 1 to the right, change to negative. So we have gotten 1 point that should not be inside the domain. Minus 1 should not be inside the domain. So we work on this quantity now. So with the help of a diagram, we have our real line, negative infinity, we have positive infinity here. At the center point, you have what, 0. I'm drawing the real line. Now, what is the numerator of this? What's the numerator of this fraction? The numerator is x minus 2, right? The numerator is x minus 2. Because we have x minus 2, if you set this numerator to be equal to 0, if you set this equals to 0, you are going to get that x equals to what? 2 by moving negative 2 to the right. So you put positive 2 somewhere here. 2 is somewhere here. Then for the denominator, you solve x plus 1. If you set it equal to 0, I set the numerator equal to 0, I solve, I got 2. You set the denominator to be equal to 0, that's x plus 1 equals 0. Because we are solving for this. If you set it to equal to 0, move close to 1 to this side, we change to negative. So x equals minus 1. So minus 1 should be somewhere here, minus 1. See what you are going to do. You pick a point at the left and the right side of 2, and at the left and the right side of 1, because this is the point we are considering. The numerator gave us 2, and the denominator gave us what? Minus 1. And the right side of 2, if you put any number here, just pick any number you like, put it here and check whether it will satisfy the inequality. So 3 is at the right of 2. 3 is somewhere here. So I can pick any point. Let me pick 3. If I put 3 here, 3 minus 2 will give me what? 1. And if I put 3 here, 3 plus 1 will give me what? 4. I will do 1 over 4. 1 over 4 is a number greater than 0, right? So this part, you tick it good. It's part of the domain, right? Then let's pick the main point 2. Pick 2 and check whether 2 will give you something 0 or greater than 0. If you put 2 here, 2 minus 2 is what? 0. And if you put 2 down here, 2 plus 1 is what? 3. So you have 0 divided by 3, which is what? 0. Which is part of it, because it can be greater than or equal to 0. So I'll mark this point 2, right? Then come to the left side of 2. Left side of 2, pick any number at the left side of 2. I know 1 is somewhere here, right? At the left side, 1 must be somewhere here. 1 must be somewhere here. So if I put 1 here, 1 minus 2 is what? Minus 1. If you put 1 here, 1 plus 1 is what? 2. You'll be having 1 minus 1 over 2, which is a negative number. But we are looking for points greater than or equal to 0. So a negative number is less than 0. So this point is cancelled. A number between these 2 and negative 1 is cancelled. So let's come to this side of let's come to this side of negative 1. Now if you come to this side of negative 1, if you pick a number from negative 1 this side towards this side, because I've told you that from 2 to negative 1, between 2 and negative 1 is cancelled because it's not satisfied. So you come to negative 1. Let's check for negative 1 first. And let's check whether the point is among. So if you put negative 1 here, you have negative 1 minus negative 2, you have negative 3. Put negative 1 down here, you get 0. So you'll be doing negative 3 over 0, which is infinity. Which will give you infinity. So because of that, infinity is not a real number. So this point is not among. Minus 1 should not be among, as we have seen it earlier. Then if you pick a number this side, at the right side, at the left side, I know minus 2 is somewhere here. Minus 2 is somewhere here. Put minus 2 here. Minus 2 is minus 4. Remember, you can pick any number, but just pick any number this side. I just decide to pick minus 2. Minus 2 plus 1 is what? Minus 1. So the answer, up 1 gave us what? Minus 4. The down one gave us minus 1. So negative will cancel, remaining what? 4 over 1, which is what? Positive. So which is part of what we are considering. So you tick this one good. So we now come so the domain now is now giving us, remember, this part is among. The negative infinity is not a real number. So we are just considering number between negative infinity and negative 1. So I'll use open bracket for negative infinity since it's not among. If the point is among, you use close bracket. Then -1 is not among, but the numbers between -1 and negative infinity. So I use open bracket for -1. Then I'll do union. I'll go to the other side that is among. From this side, 2, the point 2 is among. So I'll use close bracket for 2. 2 going upwards to positive infinity. So positive, if you write to infinity, use open bracket for infinity since infinity is not a real number. So this gives us the domain or the understood domain of this very function. Thank you so much for being part of this class. See you in our upcoming class. Bye.